Okay, in this example, we're trying to find the pressure difference between points X and Y in this sort of complicated manometer system. What we're going to do is we're going to label some of the interfaces and then find the pressure at these various interfaces. So we'll call this interface 1, this interface here 2, this one 3, and this one 4. Okay, and then we're going to work our way around. We're going to find the pressure at 1. We're going to kind of start on the left-hand side and then work our way around and eventually get to the pressure at Y. So first of all, I'm going to find the pressure at 1, starting with the pressure at X. Okay, so I'm going to find the pressure here, starting with the pressure here, and I'm moving down a distance of h1, so I'm going to add in the weight of that fluid, fluid A. I guess it's fluid A, not fluid X. And we're moving down a distance of h1. Okay, so just a couple of things here. I'm moving a vertical distance h1, that's where I get that. And then since I'm moving down in the fluid, I'm adding in the weight so that you can see the pressure is increasing. It starts at X and then it increases because I'm adding some weight of that fluid A. Okay, now let me move to point 2. I'm going to start at pressure at point 1. So I'm starting here. I can move horizontally in the same fluid, so I'm just going to move here. This will be the same pressure as at 1 because I'm moving horizontally. But now I'm moving up a distance of h2 in fluid B. So I'm going to subtract out the density of fluid B times g times distance h2. And again, here I'm subtracting because I'm moving up, so I'm removing some weight. So that's why it's minus. I'm moving in fluid B, so that's why I'm using the density of B. And I've moved vertically upwards a distance of h2. So that's how I get that. Now let's go to point 3, starting at the pressure at 2. So I'm starting here, I'm moving in fluid C now, and I'm going to move up a distance of, if you look, I'm going up this distance here. Let me just kind of draw this dashed line here. If I go up that distance there is going to be h3 minus h2. So that's this distance here is h3 minus h2. So I'm going to subtract out the density of C times G times h3 minus h2. So again, negative because I'm moving upward. I have rho C because I'm moving in fluid C, and the distance I've moved vertically upward is h3 minus h2. That just comes from the geometry. And I can go horizontally across here because I'm moving in the same fluid, fluid C. I can move over and it'll be the same density. Now, just one thing I should point out is I couldn't move horizontally this way and just say the pressure here is P2. And the reason for that is because it's different fluids. You know, here I'm at fluid B, here it's fluid D. So they're different fluids. I can't move horizontally in different fluids, but I can do it in the same fluid, like here it's fluid C. Okay, so let's go to point 4. So the pressure at 4 is the pressure at 3, but now I'm moving down a distance of h3 minus h4. So let me just sketch that in here. This distance to this point is h3 minus h4. Sorry, it's kind of sloppy there. So I'm adding in the weight of fluid D because I'm moving in fluid D here. So that's why I have rho D times G, and then the vertical distance I'm moving is this h3 minus h4. So right here, h3 minus h4. And then the last one, to get the pressure at Y, I'm going to start with the pressure at 4 right here, and now I'm moving upward a distance of h5 in fluid E to get to point Y. So I'm subtracting out the weight because I'm moving upward. Density of E, that's because I'm moving in fluid E, times G times h5. Okay. So now what I can do is combine all these together. I can take this P1, plug it in there. I can take this P2, plug it in there. P3, plug it in there. And P4, and plug it in there. And then write the whole thing out. And I guess I'll go ahead and do that. It's just kind of tedious here, but I'll do it nevertheless. So if I plug in all those things and work it all out, you can watch me write all this on the screen. It's very exciting. And there we go. We now have the pressure at y in terms of the pressure at x and all the geometry and different fluid specific weights. Okay, I think that's what we were asked for. Yeah, the pressure difference between points y and x and y. So I could rewrite it this way if I wanted to get the pressure difference. Okay, that's all there is to it. We'll end the example there.